abstract class. So I told you whenever we were dealing with all the OOPS concepts, so in Python we have only abstract classes, not interfaces. Where in Java we used to have we had interfaces, and we also have interfaces now as well. But yeah, in Python, can we achieve that concept like interface and abstract concept? So by definition, this is extra this thing interface. So by definition, interface is a class with all non-implemented methods. So if you simply have the method names, okay, if you simply have the method signature and then every method is like empty, okay, so we call that particular class as an interface explicitly in Java, okay. And the abstract class okay, at least one non-implemented method. So if there is at least one non-implemented method, then we call that particular class as abstract class. When I say at least one non-implemented method, which also means it can have at least one implemented method, okay. It should have at least one implemented method, and it should have at least one non-implemented method, okay. Yeah. Okay, this is the simple definition between the abstract and interface. And in Python, we don't have such a differentiation between these two concepts. So we still call interface as an abstract, but internally we can treat it as an interface if all are non-implemented methods. And if there is at least one implemented method and one non-implemented method, we can call it as an abstract class. Okay. Now let us see how can we create an abstract class, and how can we extend those classes. Okay. First, we need to import a module. So in order to use abstract classes, okay, the module name is ABC module. ABC module. Okay. So first we need to import this particular module. So module name itself is ABC, which are in smalls. So we know the naming convention for a module is always follow lower cases. If there are like extra words, we can use the camel case or the snake case. Okay. So first we need to import this ABC module. So from that module, so we need to also import ABC class. Okay. So we need to import ABC module, and we need to import ABC class. And along with this, we also need to import a decorator called @abstract method. These and all are required. So this abstract class and abstract method, they both are available in the ABC module itself. So we know if you want to import multiple things from a single module, so we know how can we do that. We can use from ABC import ABC numbers and abstract method. Okay. Yeah. So that is how first we need to import whatever we want to. From the ABC module, we need to import ABC class and then abstract method. So you don't need to provide @ here. Okay. We can import abstract method. So what is this ABC? Okay, you might be wondering, that is some random name that they have given. No, it is not a random name. So it expands to abstract class. Okay. AB class. That's it. Abstract class. That's it. Okay. First we need to import the ABC module. So from that we need to import ABC class and the abstract method decorator. That's it. Okay. So now that we are half ready to implement an interface, right? So once we have all these imports ready, then we can simply go for creating our abstract class. Yeah. So let me take a code block. Let me try to implement a parent abstract class. Okay. First, what we need to do? We need to import ABC class and abstract method from import module, right? ABC module import ABC. So don't mess this uppercase and lowercase. So lowercase is a module name, uppercase is the class name. Okay. Yeah. So now we have what we need. Now let us start with the same syntax how we create a class. Class. Okay. So now I am creating a class with the parent. The name of the class is a parent. Now, the only difference is, so previously whenever we were creating a class like this, so we did not have the parenthesis. Now, if we were to create an abstract class, we need to have a parenthesis. And to this parenthesis, we need to pass this ABC class. Okay, which is this ABC. So whenever we pass this parameter to this particular thing, so Python will treat, okay, this is an abstract class. Okay, so even if there is an unimplemented method, don't worry. Okay, it is a kind of give some assurity to the compiler that this is an abstract class. Don't worry if all the methods are not implemented. Okay, yeah. So now once we have our this ready, and for the abstract class methods, it is not necessary to have a constructor. When I say it is not necessary to have a constructor, what does that mean? So from previous class we know, so if and only if we have a constructor, okay, we can create an object, right? So whenever we try to create an object for this class, so it internally calls the constructor that we have seen. But when I am telling here, so we don't need that here. So when I say we don't need a constructor here, so how would that work? Because we cannot initialize an object for an abstract class. So that is why we don't use a constructor. Okay. Yeah. So since Python is putting some restrictions, not only Python, it's OOPS concepts. It's putting restriction on this particular abstract class. So for which we cannot create an object. So because of which it is not accepting any constructors. So if you try to give a constructor inside it, it will throw error. Because we are telling this is an abstract class, and internally if we provide a constructor, so it is a kind of a contradictory for Python to deal with. This is an abstract class, okay. So why is the user creating a constructor? So which is not a proper syntax. So then it will throw an error. So which is why we don't use constructors for abstract class to restrict creating or instantiating objects for this abstract class. Okay. Now we don't have constructors inside the class. Now, so when I say at least one implemented, at least one non-implemented. Now let us go with one non-implemented methods. First one implemented method. So let me first print the name of the parent. Okay, function. Parent name. Okay, so this is my function. So which currently I am implementing. Just like the previous thing, so we also need to pass self as a parameter here. Yeah. Now simply I am printing I am parent. Okay. So this is one implemented method. Now let us go for non-implemented methods. So let us have one sun class. Sorry, sun function. Okay. Okay. So now I have a sun function. So to the sun function also we need to pass self as a parameter. Now let me come back here. Self. Now we cannot leave this space as it is, because if you leave this space as it is, so Python will throw error. See, this particular thing is already noted as a error thing. Okay, how can we do that? So if you could remember, so whenever we were like having a class on the control statements, I introduced one keyword called pass. Okay, which tells the Python compiler, so even though if there is nothing here, just ignore the indentation level. Okay, so that we are going to use here to skip the indentation level. Okay, since it is a function, so it accepts something to be inside this function, so we are not implementing this particular function inside the parent. We'll implement this inside a child class. So now if I keep it as it is, so it will throw an error. Now what I'll do, I'll simply make it as pass. Okay, now let me run this. Okay, it did run, but so we since we are importing this abstract method, so which is a decorator I told, right? So we need to use this particular decorator on the non-implemented methods if we want to implement it further. Now if I give only this on top of this function, okay, so then only in the child classes it will allow me to implement this particular function. Otherwise it won't implement it won't let me implement this particular function in the child classes. Okay, so these are the simple things. What is the next step? Okay, use this particular decorator for the non-implemented methods, so then only it will allow us to implement it in the child classes. So I told you one more thing, right? We cannot initialize an object for abstract classes. Now let us say, let me implement on one more function. Okay, so this is another abstract method. Now that I have an abstract class with one method is properly implemented and two methods are abstract methods. Okay, now let me try to create an object for this. This is how I need to create, right? This is the function which we use to create the object. See, now it is throwing error. Let us see what is the error is. Cannot instantiate abstract class parent with abstract methods daughter name and son, because these two methods are not yet implemented. Okay, they are like abstract methods, so that is why we are not able to instantiate an object for this. Now let me like comment this thing out. Let me remove this. See, now it is able to create an object, because since we have at least one, we don't have an abstract method inside this, even though we are implementing this, even though we are using the abstract class as an input parameter for this class, but since there is no abstract method inside it, so that is why it is defaultly creating the empty object for this particular parent class. Okay, so if you want to restrict that, so we are going to use abstract method annotator. Okay, so then only it will be called as an abstract class, otherwise it is not called as an abstract class. Okay, now let us see how can we extend this particular parent class to a subclasses. Now let me like implement a son class. Okay, now this is my son class. So just like previously, what is the parent class that we passed? ABC is the parent class that we passed to the parent. Now for the son, so we are implementing, we are extending this parent. That is what we are passing here. Okay, so whatever the class that you want to implement, So we need to pass that as a parameter for the child class. So here son is a child class to which I am passing the parent as a parameter. Now I can implement whatever I want to. Okay, but yeah, so whatever the abstract methods in the parent class, all of them I need to at least implement them. If at all I don't have to like implement them properly, I can at least give some random values. Okay, so in that case only it is treated as an properly implemented class. Otherwise, it won't treat it as a properly implemented class. Okay. Now, okay, so all these implemented methods, so it is not required to implement here. So we only need to implement the abstract methods. Okay, but if you want to do this, you can also do this. But this will override. I will tell you with example. Def son self. So here I am implementing. I am the son. So next, I am implementing the daughter function. Then I am implementing I am not the daughter. Okay. Now let us run this. Yes, so the compilation is successful. Now, since these two abstract methods are properly implemented inside this class, now let us see if we can create an object for the son class or not. Son is equal to son. Okay. Now let us see if we get any errors. See, we are not getting any errors, and from son we can access whatever the function that we want. Son dot son name. Son dot daughter name. Okay, let us execute this. See, so the object for the son class is created because we have implemented all the abstract methods. So there are two abstract methods in the parent class, so which we have implemented both of them. So because of which we were able to successfully create the son class. Otherwise, we won't be able to create an object for this son class as well. And from there, we have accessed these two methods which are there inside this class. So what if I want to see who is the parent for this particular class? So the parent function is only implemented in the parent class. Can I access the parent method? Yes, you can access with the help of the son object. See, now with the help of the son object, I am calling the function which is inside the parent class. Now let us see. See, it is accessed. So the question to the answer, the answer to the question. So if we cannot initialize an object to an abstract class, how can we access the implemented methods? This could be a question. Okay, if you are not able to, see, if you are not able to create an object for an abstract class, so how can we how can we access the implemented methods? See, that could be a question, that could be a doubt as well. So in interview someone will ask, so yeah, if as soon as you told the definition of an abstract class like this, so there is at least one implemented method and one non-implemented method. So if there are like implemented methods inside an abstract class and you are telling we cannot instantiate an object for this abstract class, then how are we going to access the implemented functionalities? We cannot access the implemented functionality as it is. So if we want to access the implemented functionalities, so we need to first extend this particular abstract class. Okay, so that is what we call it as inheritance. Okay, inheritance lets us to access them. So here what we did, So if I can speak in the terms of OOPS concepts, I can say, so this is an abstract class, so where I have achieved the abstraction, and this is an inherited class. There are so many names for this. Inherited class or subclass or child class. So whenever we call with this name, so you don't be confused. Inherited class, subclass, child class. At the same time, we have names for this as well. Main class and the parent class. Okay? Yeah. So this is a main class and this is a parent class. Also a parent class. And these are inherited classes, subclass, child class. And inherited class can also be an abstract class. How can it be? Now let's see. See, parent is an abstract class. We know that because it has two abstract methods. Now what I am doing, I am implementing this parent class, okay, with the son class. Now inside that, previously I have implemented two abstract methods. Now what I will do, I'll implement only one abstract method. Okay. So we call a class as a proper class if and only if it has all the functionalities implemented properly. Now if you could see, son class is an inherited class from the parent. So it will inherit all the functionalities from the parent. So now it has inherited three functionalities. Okay. So out of which parent name is already implemented, son name which is implemented in the subclass, and daughter name which is not even implemented yet. Now this is also an abstract class. So on a top level, you could see this is a proper class. But if you dig into the inheritance level, so you could see this is also not a proper class. So we should not be able to get an object for this. Now let me run this. See, now we are getting an error. It says the daughter name is not properly implemented because if you could see, there is no implementation for the daughter name function. Okay, that is why still this particular son class is also treated as an abstract class only. That is why we are not able to create this object for this particular son class. That is when I mentioned, so whenever you want to implement this particular class into a child class, so whatever you want, you just implement. If you don't want something, just skip them. Okay, yes, but don't leave them. So if you don't want something here, you can simply put a pass. That is not an issue. Okay, let me comment this out and simply put a pass here. If you don't want to implement this functionality inside this particular class, you can simply pass that, but don't leave that particular thing as it is. See, now it got executed. Okay, yeah. So now even if you call the daughter name function, it is not throwing any error because it simply has nothing. So that is why nothing got printed. Okay, yeah. Now, so let me inherit one more class from the same parent class. I'm like building the hierarchy. This hierarchy we call it as inheritance levels or inheritance tree. Class. Now I am implementing a daughter class. Okay. So this daughter class is coming from the parent class only. So now I am passing parent as a main class for this. Now I need to implement. I need to have son name at least. Okay. Even though I don't have any implementation inside it, I should have this thing. Son class, sorry, son functionality. Now let me implement the daughter name functionality. Okay, here I will print. Here I am saying I am the daughter. Okay, now, so just like son, we can create an object for the daughter as well. Okay. Just like that, because see, we are able to create the object for here because we have implemented, we have added the both abstract methods inside this. Even though we don't have implementation for one of the class, we have added it. Okay, that is why we should be able to create an object for this. Now let us call all the functionalities in the hierarchy. Dot son name. So for which we don't have any implementation. For this we have an implementation in the child class. Okay, so for this we have an implementation in the parent class itself. Now let us run this. Oh, there is a spelling mistake here. Yeah, see, these two are printed from the with the help of the daughter object. These two are printed with the help of the parent object. Now if you could see the hierarchy level here, hierarchy or inheritance level. So at the top we have parent. Okay, so parent is implemented by son and also daughter. Okay, just for the indication I am keeping this as an abstract class A. I for the implemented class. Okay, see, now this son and daughter are the parents, I mean child of this particular parent. Okay, now what if I want to build another hierarchy with the same parent. Let's say the parent, let me print a parent name here. Instead of this, parent is equal to Bob. Okay, Bob and Alice. Okay, so these are the parents. Now I want to build another hierarchy with the same parent. Okay, now in that the parent name should be different. How can I do that? Okay, so now these two are the sons and daughter of this particular Bob and Alice. Now I want to like implement similar classes for the children of Jacob and Johnny. Okay, let us see how can I do that. So class son1, just some random name I'm giving. Okay, so this is also getting implemented from the same abstract class. Now inside this I'll have the same son name function. Okay, inside it I'll just simply print I'm son1 and daughter name self. So I'm passing from here. Now see, I told this particular son1 is a son of Jacob and Johnny. Okay, now but here the parent class says the parents are like Bob and Alice. How can I change that? So since this is an already implemented method, how can I modify it? Yes, we can modify it. Even though it is already implemented, you can modify it. Okay, yeah, now let me modify it here. I will tell you how the hierarchy works. Here I am implementing the parent name again. Okay, print okay, so now these are the this is the son1 for Jacob and Johnny. Now let me comment these things out and create an object for son1. Okay, now let me call all the functions. Son name, daughter name, parent name. Okay, see, this son1 is implemented from parent. Now here I have modified the implementation for one of the abstract method, and the implemented method is changed here. Okay, so here the parents are Jacob and Johnny, but it is not printing this particular function. How is this happening? Okay, how is Python compiler or any compiler, whoever is using this ops concept with the help of inheritance, how are they resolving such a kind of issue? So if you could see, the same function parent name is available in the two classes. Okay, it has two implementations, not the two classes, it has two implementations in the same hierarchy. Now let me build on one more hierarchy here. Okay, here there is a sun1 which is implemented from this. Okay, so the same yeah, so here if you could see this particular with the help of sun1, so I'm accessing this particular parent name. Okay, so it is in the same hierarchy. So parent also has the parent name function and sun1 also has the parent name function. Now whenever I am calling sun1 dot parent name, so which one is presiding? Okay, which one has more priority? I mean, which one to pick first? It is obviously the child class. The child specific classes have more priority over the parent specific methods. Okay, that is the conclusion that we can draw from here. Okay, so whenever you call a function which has multiple implementations in the same hierarchy, let's say here I have only one hierarchy. Let's say even son has implementation for the parent one, daughter has implementation for the parent one, and son one is again extended. Maybe for his also they might be like children. So for that also we can extend the classes. But yeah, obviously, so with what object we are calling this particular implemented function, so that only prevails. So if the implementation for that method is not available in that class, then it will go for the one level hierarchy top. Just like what happened previously. If you could see, in the class son, we don't have implementation for the parent name. That is why even though we call son dot parent name, so first it will check in the child class, which is son class. So do we have an implementation for the parent name? No. So if it is not available here, then it will go to the parent class. So it will check in the parent class. Oh, here there is an implementation here. So that is when it went here and printed this. That's it. Okay. That is the only thing that we need to remember. Yeah. Okay. So that is pretty much on the abstraction and the inheritance. Okay. Yeah. So polymorphism is the last thing that I mentioned, right? So see the parent name which is coming from two classes in the same hierarchy. So how is it getting resolved? And I told you polymorphism is the something which is done at the runtime, during the runtime. Okay. So during the runtime it will like resolve this particular issues. So which method to pick, which method has more priority? If that is not available in the children class, so which class should it go? So that is all the things that polymorphism will take care about. So we don't need to worry about that things. Okay? Yeah. So yeah, now we are like done with abstract classes and everything on the classes. Now let me mention one more thing called Dunder methods or magic methods. Okay. Mm-hmm. So Dunder methods or magic methods. So we already know one of such a kind of method, which is a constructor method. I told you. Okay. What is Dunder method? So it has double underscores before and after. That's it. Okay. Okay, so what is the purpose of this magic methods or Dunder methods? Okay, so they are called as magic methods because they perform some things which we cannot simply do that. Okay, that is why we call them as magic methods. So if we were to do the same kind of task in Java, okay, so it is a very tedious task. But in Python, because of this magic methods or the Dunder methods, so it is making so many things very much simpler. Now let us see what they are and how they are helpful. Okay? Yeah. one more thing we need to remember is, so these magic methods are not user defined methods, so they are like already coming built-in methods. Okay, that means we have some specific keywords which are reserved for this magic methods. Not only for the magic methods, so there are like specific keywords, str, eq, something like that, so which we can leverage. Okay, and put some underscores before and after, so we can call that particular thing as Deuter method or the magic method. Okay, okay, let us say we have a keyword. Okay, let's say this is a keyword. So if you want to achieve this particular keyword in the terms of classes, let's say if you want to achieve equality, uh, let us take an example that would be more better. Okay, so now, so equality keyword is eq. Okay, so for simple strings, okay, for simple strings or for simple numbers, how can we achieve whether these two are same or not? How do we do that is like 12 equal to 23, like this. Okay, equal to sign, and aba equal to aba. So this is an equality function on top of simple data types which are like already existing built-in data types. Now if you want to achieve this equality operation in terms of classes, okay, how can you achieve? So you can achieve this equality operation in with respect to the classes with the help of this eq keyword and combining them with the Dunder methods or the magic method syntax. Now, so if you want to achieve the same thing, how you can write the function is like this: double underscore eq and double underscore, that's it. Okay, so that is how you will create a function or a method, so which we call it as an equality magic method or magic methods. Okay, like that. Yeah, this is just an example. So if you were to like define this in a proper way, so yeah, let us define. This actually defines a specific behavior to be achieved. Okay, on instances. I told you, so this is most of the classes or objects. Okay, if you want to like achieve or define some specific behavior which you want to execute, okay, at that time you can like leverage these methods. You can take help from this methods. Okay, so there are certain types of things here also, just like our operators. Here also we can use this magic methods for doing some different operators. Let us go one by one. First type of operation or behavior that we can achieve is construction. Construction of an object. So we already know this. In order to construct an object for a class, we use construct class, right? Constructor method, which is init, which is also a Dunder method. Okay. Now, second, string representation. So we have this entire class, right? So if you want to represent this class as a string, how can we do that? So in that case also, we can simply excuse me, we can simply define how we want the behavior under this particular string representation magic method. Okay, there are two things: str function and double underscore rstr. Okay, so these are the two functions which you can use. Okay, so rstr is an old function. Yeah, we can use the newer one which is called repair function. Okay, so you need to like have this function inside your class and implement however you want to. Okay, the implementation is there is no restriction on how you implement. The restriction is just you just need to, if you want to achieve such a kind of behavior, you can simply use this particular thing. Okay, it is not necessary, but I don't think you can skip this topic entirely, because there are some ways, there are some use cases wherein we wanted to use this. So that is why I'm introducing this magic methods, which will be pretty much useful in the next topic called operator overload. Okay. So next, let us go to the next type of operation, object comparison. Okay, this is similar to the comparison operators. But in the comparison operator, we were comparing simple data types, right? The numerics and strings. That's it. Okay. So here, yeah, there are multiple methods, just like our comparison operators. Okay. Yeah, just like that, we have multiple functions here: equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to, just like that. Okay. Equal to function, not equal to, less than, greater than, less than or equal to, greater than or equal to. But yeah, see again, so if we are like comparing, if you are doing a comparison, it is obviously comparing more than one, right? So here there is a restriction, you can only compare two objects, that is right. So this functions, so whenever you are implementing this function, so the input parameter to this function should be, one is a self and other should be other. Okay, that's it. What do you want to compare with? The self means the current object, other means what is the other object that you want to compare with the self object. That's it. Okay. But these things, initialization string, so they can simply work with self. And if there are some input arguments for this, yeah, you can pass them. But yeah, for this str, you can simply leverage self, because this string representation is only for the current class, right? I mean the current object. Yeah. So the next type is the next type of operator, which is arithmetic operator. Okay. Arithmetic operations on objects. So see, if we are doing arithmetic operation, that means we are summing up two values. We are summing up two values, or we are subtracting two values. We are multiplying two values. Something. There are like more than one. So in that case, if there is more than one, then obviously the input parameters should be self and other. Okay. If you are dealing with more than one, then yeah, input argument should always be self or other. Okay. Add, if you want to add. So multiply, just like that. We have all the things available: true division, float division, power, modulus, like that. Okay. True division, float division, modulus, exponents, like this. Okay. Yeah, so we'll see an example for in operator overloading with the help of these functions. Okay, arithmetic operators. Next type of operations, which what did we see? So now the container operation, like the container operations like length, such a kind of things. Okay. So this will tell us the length of the particular thing which we want to. Let's say inside a class, if you have a list, okay, so you can, like, instead of applying instead of like going inside the object and taking out the list and checking the length, so instead of that, you can simply implement this particular length function. So whenever you call this length function, it will give the length of that particular object. Okay. Yep. Next, the iterable features. So we have talked about this iterable features so many times, right? So there are two main functions, okay, inside this iterables. So if you want to like have this particular thing as an iterable, so we need to implement two particular things: itr, so iter, and the next. Okay, so these two functions are very much necessary. So let's say if you are defining your own sequential data type, okay, so in that case you need to implement these two functions. Okay. Yeah, so this is pretty much on the magic methods. Okay, now we'll see a few examples, mostly on the arithmetic operators that I will take. So that we'll call it as an operator overloading topic. operator overloading. So what is the overloading means? Okay, so overloading is, so let's say if you have a plus b, okay, how will this be executed? Okay, we cannot simply tell that, right? We can simply tell that first of all, what are the data types for this? Let's say let us take an example for plus only. Okay, yeah, plus. So what is the operator? This is an operator, right? This is an addition operator. Okay, but how it behaves based upon the input data or the data type is what we call it as overloading. So for different kinds of data types, it acts differently. Let us say this plus operator acts differently for numerical data types, strings, and class objects. Okay, so this particular plus itself has three kind of implementations. It is getting overloaded three times. So for numericals it will do addition, for string it will do the concatenation, and for class objects, so it is up to us. Okay, if you want to achieve string concatenation, yes, we can achieve on the class objects, which are user defined data types. And if you want to achieve numerical addition, yes, you can achieve them. Okay, again, that is on the user defined data types. This is what we call it as an operator overloading. For a same operator, if we can have multiple kind of implementations based upon the data type, so that we call it as an operator overloading. That's it. Okay, overloading is more than one implementation. Operator in the sense, this is overloading with respect to the operator. That's it. Okay, for a simple operator, if you have multiple kind of implementations, okay, varying with the data type, that is what we call it as operator overloading. Okay, that's it. And yeah, so is this like applicable for to everything? Okay, yes, it is. As I have mentioned, it can apply for numericals, it can apply for strings, it can apply for class objects. Okay, for class objects, it depends upon user implementation. For numericals, it acts as an addition. Let me put it here. Addition. For strings, it acts as a concatenation operator. Yeah. So just like let us take another example with asterisk. Okay. Yeah. Similarly, for numericals, it acts as a multiplication operator. Okay, for strings it is a repetition operator, and again for class objects follows user implementation. That's it. Okay, so this is what we call operator overloading. Now, how can we achieve this operator overloading in terms of classes? Now let me take an example. Okay, so let me take an example. Let us take a class called subject class. Okay, so inside the subject, what I'll have is each subject wise marks. Okay, not subject wise marks. Okay, for each subject, how many marks? Okay, inside which I have, it is a class, subject is a class, so inside which I have the detailed subject name. Okay, marks. Okay, I have subject name and marks, so this is a class. For a student, let us take he is currently pursuing some degree in which he has like only 4 subjects. So at the end, we want to find out what's the sum of marks for all the 4 subjects. But yeah, internally for this particular student, we will be having 4 subject objects. Okay, inside each subject, we'll have subject name and the marks, subject name and the marks, subject name and the marks. So if you have 4 different objects, how can you sum up all these marks? So one thing is the traditional way of doing it. So in Java, how we do it? So first, create a list of subjects. Okay. And the second is an iteration. Okay. Third is uh, take out the marks. And fourth one, keep a track on the sum. Okay. So these are the 4 steps that we traditionally do. So if you want to achieve similar kind of functionality in Java. But yeah, since in Python they have introduced this topic called operator overloading. So now what we can do is we can simply say we have 4 subjects, right? Let us call subject 1, subject 2, subject 3, and subject 4. Okay, let us have 4 subjects. Now in Python, how we can do the same thing is we can simply do it like this: s1 plus s2 plus s3 plus s4, just like this. Okay, so we can do it like this in Python. This is Python. Okay, so in Python we can do something like this, but in Java, if you could see, we did like this. Okay, yeah, so that is the help of this operator overloading. So here we have used this plus operator, right? So if you could see here, which can be used on the class objects as well, but user need to define this particular functionality, how it should behave. So for that we can leverage the dunder methods or the magic methods. So since we are doing addition methods, so our responsibility is to implement the add method. That's it. Okay, now let us take an example. Let me have a class. Okay, so let me call it as some vector. Okay, let me call it as a vector. Okay, let me define a constructor. Init self. So to this I am simply passing 2 values. Okay, for this class I can only have 2 values, some a and b, I would say. Okay, self dot a equal to a, self dot b equal to b. Okay, now that I have my constructor ready, now I want to implement this addition functionality on my objects. Okay, now how can I do that? Now first I need to write some behavior or the implementation for the dunder method called add. Okay, add. So if you could see the signature for this add, so it is adding 2 things, that means self and should be other. Okay, now we need to have self and other, self comma other. Okay, so now we have self and other, that is right. Now what is the functionality that I want to implement? So I have 2 objects, self object and another object. Now what I need to do, I need to add this corresponding values. Let's say I want to add a plus a, b plus b, a from self, a from other, and b from self and b from other. I want to add that and return a new object of vector. What I can do, return, okay, vector of, I'm like creating an object for the vector here, vector of, now what I need to do, self dot a plus other dot a. Okay, in similar manner, self dot b plus other dot b. So this is how I am giving it. Now let me run this. So this is an operator. There is an operator called addition. I am overloading it simply with the help of this magic methods. Now let me create some objects for this. Let us see v1 vector. Okay. Let me call it a v1 1 comma 2, and it would be vector 2 comma 3. Okay. Now let me see v3 is equal to, I can simply do it now like this, v1 plus v2. Okay. Now let me print v3 dot v3 dot a and v3 dot b. Okay. Yeah. See, it simply did it, and it is very fast. If you could see in the fraction of milliseconds, so we got the output. But if we were to go by the traditional for looping, so it has to run a loop. Okay, so it is a very tedious work, right? Yeah. So we are overloading this addition operator here, and in a similar manner, so if you want to overload some multiple things, yes, you can do multiple things. Okay. Yeah. Now let us go with the same arithmetic things only. Now I want to implement the multiplication feature. Okay, multiply. So for this also I need self and other objects. Okay, from here I am would be returning vector object self dot a into other dot a, comma self dot b into other dot b. Now I can call v4 is equal to v1 into v2 into, now I can use v3 as well now. Okay, because we have v3. Now I'll print v4 dot a v4 dot b. Okay. Yes, see, 1 into 2 into 3 is 6, and 2 3 5 is 30. Yeah, so that is how we can achieve this simple operations, okay, with the help of this magic methods and the operator overloading feature. So we can achieve this complicated operations in a very simpler way. Okay. Yeah. Okay, so that is pretty much on this operator overloading, and you can also explore this multiple kind of magic methods. Okay, in case if you need. Otherwise, I have just given some glimpse of it. How can we use it? Yeah, you can simply use them. Okay. Yeah. So this is pretty much on the advanced topics as well. Okay, so we have covered classes, and in that we have covered how can we create an abstract class, and how can we create subclasses for that, and magic methods, and decorators, which we covered 2 weeks back. And also we have covered exception handling, which is a part of advanced topics only, and modules, packages, oops, concepts, everything. So we have like touch based everything under the advanced topics of Python. Okay. Yeah. So so that is it, guys. Okay, so we have covered everything under the Python. So if you have any doubts in future, yes, you can reach out to me. And if you need if you feel I mean some of the topic, and if you want a class for that topic, yeah, feel free to like ping me the topic. I can take a class on that. But I have covered most of the topics which would be like useful for you, even if you go for the development for a developer role, and for an engineer, data engineer or data analyst role. Okay, so you can write the scripts, you can write some simple files, and you can also create an application, okay, with the knowledge that you have gained with from this class. Okay, but in case if you feel something is missing, yeah, feel free to like ping me. I can take a class on that. Okay. Yeah. Thank you.